seconds and counting. Commander Dave Walker, in the process of performing a test of the transfer capability between the primary ascent computer redundant set and the single backup flight system computer. That's between the four computers which work together and the one backup. This test verifies that critical guidance data can be transferred from the redundant set of four simultaneously operating computers to the single backup, and that the computers can operate in a synchronized manner. Throughout the countdown, the computers talk back and forth to each other, assuring each other that everything is fine and that they all agree with each other. This test is to ensure that in the remote possibility that the four primary computers shut down during ascent, that the single backup computer could take over and flight would continue safely. The leak checks of the cabin have been completed. The orbital maneuvering system gaseous nitrogen tanks have been pressurized for launch at this point. Gaseous nitrogen is used to operate the valves, allowing the hypergolic propellants to flow into the engines. That system will now be ready when the onboard computers command the OMS engines to fire for the first time to put Atlantis into its initial orbit. And the NASA test director has asked that the post-launch inspection and safing teams be asked to report to the assembly area at roadblock A11. For some people, the launch is the end of their task for the day, but once the space vehicle leaves the pad, there's still a lot of work for others. They must make sure all the various propellant systems are drained or otherwise made safe for people to start work and prepare the pad for the next launch. The countdown clock continuing at T-minus 27 minutes, 55 seconds and counting. This is shuttle launch control.
COSC, LPS, OTC. COSC, go ahead. LPS, OTC. LPS, OTC, 212. Okay, COSC, I want to kick you off on step 724, setting up your plotters. Copy that. LPS, OTC, 212. COSC, could you see if you could raise LPS there over on 127? Copy that. ISL, OTC. This is ISL? Yes, sir. Step 739. Will we perform that? Affirmative. 739 through 742 is complete. Copy that. Thank you. ISL, OTC. ISL? Okay, are you ready for the MEC pre-flight bite check? Affirmative. EPD, OTC. EPD, we've completed 749 and 750. The bite is good. Did it by the clock. Copy that. And we'll take non-performs on 752, 53, and 54. Copy. OTC, CWS. Go ahead. I'd like to verify step 722. Copy.
This is shuttle launch control at T-minus 25 minutes and counting. A pre-flight test of Atlantis' master events controller has been completed. The master events controllers relay commands from the orbiter's computers to fire explosive charges to separate the tank and twin booster rockets from the orbiter in flight. Ground support equipment has been activated that contains the pyrotechnic initiator controllers, or PICs. These are solid-state devices that arm, fire, and disarm the Space Shuttle pyrotechnic initiators used on the SRB hold-down post. These are explosive bolts that release the solid rocket boosters at the time of ignition. Also, it's been armed for starting the hydrogen burn-off sparklers, the T0 umbilical, and the external tank vent arm release systems. The NASA test director is about to verify to safety that the closeout crew rescue locker equipment has been replaced and the lockers secured. The White Room personnel have secured the White Room, and they will be going down to the pad surface in the near future. They are completing the door plugs at the present time, and they have already rolled back some of the seal that's used when that White Room is against the orbiter to prevent any weather conditions from affecting the White Room conditions. The NASA test conductor is asked to be notified when all non-essential personnel have cleared the blast danger area and the roadblocks. A recent weather briefing showed that the weather is still forecast to be go at the time of launch at 2:24 this afternoon. The main concern here at the Kennedy Space Center has been crosswinds at the shuttle landing facility, and the winds are in the process of coming around. They're expected that by shortly after 2 o'clock that they will be from the east-northeast at 10 knots, gusting to 15, and that would be satisfactory. At the present time, they are not at that. They're coming more from a westerly direction, and we are expecting, though, that a sea breeze will kick in at the appropriate time and allow us to go today. The countdown clock at T-minus 22 minutes, 21 seconds and counting. This is shuttle launch control.
Go ahead. Support step 20 is complete. Okay, copy that. That's step 706. Can you verify the ECS air dampers closed? That's verified. And chamber ECS air dampers open? That's verified. Copy that. Thank you, sir. Okay, we're looking for a go on your command to break the White Room down. OTC, CDPS. Go ahead.
Atlantis, Houston.
We need to verify no bugs by item 25 on 53. Stand by 1 DPS. That's time critical. We need to get that for JLS.
Houston, Atlantis, loud and clear, CDR.
You're loud and clear also. PLT, how do you read?
Houston, Atlantis, PLT has you loud and clear.
You're loud and
This
clear
is
also.
shuttle launch
Houston, how do you
control
read?
at T-minus 21 minutes and counting. We're just 1 minute away from the first of 2 final built-in holds. This one will be a 10-minute one at the T-minus 20-minute point.
MS3, how do you read?
The primary computer guidance data obtained as a result of the inertial measurement unit alignment has been transferred to the backup computer to ensure that both systems have the same information. In case of a prime computer failing during flight, the backup would take over control.
CDR, OTC.
The commander, Dave Walker, and the crew have been directed to begin what are called SIMO voice checks. This is actually voice communication using 2 of the channels that are used for communication back to the Mission Control Center and to the Launch Control Center simultaneously. And it's important that there not be an echo on those lines. So one is a backup to the other, and they're run together. T-minus 20 minutes and holding.
Affirmative, no bug item.
This is a 10-minute build-in hold. During this period, all computers in the firing room or control room are configured with the proper programs for the final portion of the countdown. When we come out of the hold, Atlantis' onboard computers will transition into what's called the Ops 1 configuration, which is the terminal countdown configuration. Also during this hold, the orbiter's inertial measurement units will complete their pre-flight alignment and will go into the inertial mode to account for the Earth's rotation between now and launch time. The countdown clock holding at T-minus 20 minutes. This is shuttle launch control.
OTC, COFC. Go ahead. Yeah, I'd like to report steps 0724 complete at this time, and 0725 through 0729 are also complete, and I'd like to report that GNC SCAR spinner plotter setup is complete for 7:30. Copy that.
OTC, CFCT.
Go ahead.
Can we get a CMQC over on 153 for the fuel cell purges?
CMQC, OTC.
CMQC, I copy.
Thank you. OVCC, OTC.
Go ahead, it's OVCC.
Okay, I'd like you to just stand by there till our cabin vent's complete, and then we'll break down.
Say again, please.
I'd like you to stand by till our cabin vent is complete, and then we'll break down.
I copy. We're going to do a tile inspection right now.
Okay, go ahead. Okay, LTC, TP. Go ahead. Reference tile, the original problem reported by OOS is a known discrepancy. Copy that. Thank you. OTC, TP. Go ahead. Yeah, let's see, I'd like to speak to CISL over on his net 145. ISL, OTC. This is ISL, I copy, 145. OTC, PD. Go ahead, PD.
Yes, sir. Can you send a CMQC to channel 151?
CMQC, OTC.
CMQC.
Need someone on 151 with EPD. Copy. ECL, OTC. CCL, go ahead. Yeah, how close are we to completing the cabin vent?
Yeah, I can give you step 0770 this time.
Okay. Okay, copy that, sir. CDR, OTC, air to ground 1.
CDR, go.
Yes, sir. On panel 01A1, can you report cabin pressure?
Well, we can report it. It's still reading 14.9.
Okay, I copy that. Okay, and ECL, step 772.
Yeah, we're reading 15.05.
CDR, OTC.
OTC, CDR, go.
Yes, sir.
This is shuttle launch control at T-minus 20 minutes and holding. We have exactly 4 minutes remaining in this 10-minute build-in hold. The NASA test director has been asking each of the systems engineers to report back on their respective test conductors that the proper programs are running in their consoles and that their systems are operating properly.
OTC, OTC.
NASA test director Ron Phelps is about to brief the launch team on recycle options during the remainder of the countdown.
Thank you, sir.
Basically, from now till T-minus 31 seconds, any of the console operators can ask that the countdown be held if a problem is identified. After 31 seconds, however, any unplanned hold would result in an automatic cutoff of the countdown and a recycle to the T-minus 20-minute point. Because of the short launch window today, that would result in scrubbing today's launch. The closeout crew is finishing up their work up on the 195-foot level and the orbiter access arm, tying back the various portions of that weather protection system that fits up against the orbiter. Some of the closeout crew making use of safety devices while they work on that arm. Even though the primary objective of the STS-30 launch is to successfully deploy the Magellan spacecraft, there are several other experiments which will be carried out on orbit. One is called the mesoscale lightning experiment, and this basically takes advantage of the onboard cameras simply to take pictures of thunderstorms as they fly over them at night. They are working on a lightning mapper sensor to fly on a GOES satellite and are hoping to obtain additional information from the shuttle to be used in the development of that mapper sensor. Astronauts on previous flights have reported something called sympathetic lightning, and they want to learn more about this phenomenon. Sympathetic lightning basically is the seeing of one stroke of lightning, then triggering strokes adjacent to it. Some of the scientific objectives of that particular experiment is to measure the horizontal dimensions of the cloud-top lightning emissions. They've been measuring this from aircraft, but they can't see a view taking in hundreds of miles as you can from the orbiter. On STS-29, astronauts took some video footage and to try and determine if one lightning discharge can trigger another in another cloud. And while it doesn't appear to be enough energy to do that, it may nevertheless be happening. Another experiment is the microgravity research fluid experiments apparatus, which is operated by and designed by Rockwell. This is a fluid experiments apparatus and is part of a joint agreement between Rockwell and NASA. The information used in optical glass research, monodispersed latex reactor, crystal growth experiments. The work in this with this device began in the 1980 time frame, about the time that organizations were taking a look at what materials research could be done in space. On this flight, a floating zone crystal growth experiment will be conducted, in which a crystal or non-crystalline material can be melded, and then through attaching a small seed crystal, progressively melding along in this case a wire, see if the material takes on the same structure as the seed crystal. In this way, it may be possible to propagate crystal structure through an entire sample, whereas on the ground, crystals would be very, very small before they completed their growth.
Go ahead. Passes in 101. We're ready to take BFS.
A number of materials are of interest in the industry, such as cadmium, telluride, indium, antimony, gallium telluride, and gallium arsenide.
One for your checklist.
The experiments on board the shuttle begin with low melting point materials. The countdown clock picked up once again at the T-minus 20 minute point and is proceeding. We're at T-minus 18 minutes, 37 seconds and counting.
All LDBPM you reach for remainder of countdown.
The purge of the 3 fuel cells is underway to clean the plates of hydrogen molecules which want to stick there and decrease efficiency. This purging is done by flowing hydrogen at a high rate through the cell. The data processing engineer has confirmed that the onboard computers are in the process of making the transition to the terminal countdown configuration.
You have a go, AFM.
Commander Dave Walker in the process of placing the backup flight computer in the same Ops 1 countdown configuration. Just past the T-minus 18 minute point, and Commander Walker has confirmed the backup computer is in the proper operational mode.
PVD, OTC. PVD. Yes, sir. Step 787, 88, 89. Will they be performed? Affirmative. Copy that. And I'll give you a go on that, sir.
T-minus 17 minutes, 30 seconds, and counting.
OTC, sir. Go ahead. Verify step 796 and 797. Copy that. CBFS OTC. Go ahead. Yeah, can you verify 793?
Yes, sir. And the RAS number is 030.42. And also, I can verify step 921. BFS is ready for uplink.
Copy.
Past the 17 minute point, and Commander Walker reporting that ready for the backup flight computer uplink. Dumping of the Ops 1 program stored in the memory of one of the 4 redundant general purpose computers has started, and this takes approximately 7 minutes to complete, after which engineers will examine the data for any miscompares. The flight control engineer in the process of checking critical surface driver currents and positions in preparation for hydraulic activation. Hydraulic activation occurs when the auxiliary power units are turned on at T-minus 5 minutes.
I can verify that.
That's the end go.
T-minus 16 minutes and counting. The data processing engineer reporting that the backup flight system is in synchronization with the primary system and the system ready for Houston to transmit their pre-flight uplink command to the backup flight system.
Copy that. CEPP OTC. CEPP OTC. 212.
T-minus 15 minutes, 19 seconds and counting.
En route for the verifying.
Copy.
Coming up on the 15-minute point in our countdown, T-minus 15 minutes and counting. Water levels in the water spray coolant boilers are being checked and have been verified to be sufficient for the mission. The cross-feed valves between the orbital maneuvering system and the remote control system are being configured for launch. The orbiter test conductor asking pilot Ron Graby to read out the quantities of propellants in the reaction control system tanks.
Configuring pass and VSS horizontal set.
Copy. Houston flight, OTC.
Coming up on the 14-minute point in our countdown.
Go ahead. May I speak with TPE on my channel 145? TPE, OTC, copy 145. Thank you.
T-minus 14 minutes and counting. During the last minute or so, security has reported to NASA test director that all non-essential personnel have cleared the blast danger area. There are only a few people left within the area and are located at forward observer sites.
And flights on 212.
Purge of water from the onboard fuel cells has been completed. Water is a byproduct of the production of electricity by combining the hydrogen and oxygen in the fuel cells.
Hey, Sidwell. Step 933 through 937 will work per the clock.
Copy.
OTC, CPVD.
Go ahead.
All vent doors are
Okay,
At the present time, the fuel cell electrical loads are being adjusted to between 250 and 290 amps.
NTD is flight 212.
Roger, you can do your BF pre-flight uplink at this time.
Okay, in.
T-minus 13 minutes and counting.
NTD SDM 212. Go ahead. We have a go on sequence 160953, sir. Yes, you can deactivate. Copy that, sir. Inward. Okay.
OTC, PLT, horizontal set config complete. Pass and VSS.
Copy that, PLT, and PLT, you can configure the ohms interconnect per your checklist.
PLT, rather.
Go ahead, Frank.
Coming up on the 12-minute point in our countdown.
All is interconnect configured complete.
Everything going smoothly on board. T-minus 12 minutes and counting. We are counting down to the T-minus 9-minute point where we will be holding for 40 minutes. The Landing and Recovery Director, Chuck Henschel, is verifying that all contingency support operations are ready for launch and emergency aircraft and personnel are on station.
PLT, OTC.
T-minus 11 minutes 30 seconds and counting. The dump of the general purpose computer is completed at this point, and the memory now to be compared with that of a ground-based computer to ensure that there's no unexpected bits of information in it which would cause a problem during the flight.
Copy. OTC, TP. Go ahead, TP.
T-minus 11 minutes and counting.
The
The flow rate of conditioned air being blown through the orbiter's payload bay has been reduced, and it will be verified to be approximately 170 pounds per minute.
26:58 in that time frame. And again at 17:29:10.
NTD, say again for SPE.
And we're wondering why that happened.
OTC, CPVD.
Go ahead.
That sounds like the time frame when we're reconfiguring vent doors 1 and 2 right-hand side.
Okay, copy. That'll do it. Thanks, sir. Thank you, PVD. NTD SDM.
OTC, PLT, MTS, helium reconfig complete.
Copy.
Coming up on the T-minus 10-minute point now. T-minus 10 minutes and counting. Just 1 minute away from entering our final build-in hold for the countdown of STS 30. The status of the vehicle is go at this time, and onboard computer programs have been examined and verified to be the proper one. All aero surfaces and actuators that will steer the vehicle through powered flight are in the proper configuration, and the flight crew has completed their cabin leak checks, communication checks with the launch team and flight controllers at Mission Control.
Go ahead. Yeah, give you a 965 and 966. 967 is not performed. Copy.
Coming up on the 9-minute point in our countdown.
Go ahead. 956 is complete. Copy.
T-minus 9 minutes and holding. This is a 40-minute build-in hold, and we'll resume the countdown at 2:15 p.m. Eastern Daylight Time. As we come out of the hold, the ground launch sequencer takes over control, issuing commands for the final critical tasks and monitoring as many as 1,000 different measurements during the final 9 minutes. At this point, all firing room personnel switch to the same communication channels and stay on it through launch. You'll be hearing the mission control update the commander and pilot on the return to launch site abort altitude settings and runway, and they'll put that necessary information into the onboard computer. At the present time, it appears that that would be a landing on runway 15. During this 40-minute hold, the payload people who are monitoring and controlling the Magellan spacecraft will be working a problem which they have, which they believe is based on the high power of the transmitters at Mila, the Merritt Island tracking station. At the present time, they are taking a look at a dropout in some data being received back.
Okay, sir, you've got to go on that.
The primary objective of the STS-30 launch is to successfully deploy the Magellan spacecraft and to place it on an approximately 15-month journey to Venus. It's been 11 years since NASA has launched an interplanetary spacecraft, and the hopes and dreams of many scientists and ordinary people are riding on it. They're also excited because it's the first in a string of spacecraft to be launched during the next few years, which would result in a rich load of new science. The Magellan spacecraft will provide more data than has come back from all of the interplanetary spacecraft launched in the past put together. Scientists may spend as much as 10 years or more studying that information, and it will be followed by Galileo in October to study Jupiter, Space Telescope to allow astronomers to see objects near the edge of the universe and increase the resolution of those closer than that 50 or more times. Cosmic ray observatories and several other great observatories are going to look at the universe in a whole new light that can be shed by creating eyes to see different wavelengths of radiation other than the narrow band seen by our eyes. The Magellan project was conceived and has been managed by the Jet Propulsion Laboratory, which has managed many of the nation's interplanetary probes. The spacecraft was designed and built by Martin Marietta Astronautics Group in Denver, and the primary instrument, the synthetic aperture radar, was built by Hughes Aircraft Company's Space and Communications Group. Magellan is designed to do the highest resolution topographical map to date of the surface of Venus using that synthetic aperture radar.
TLT.
Despite its sophistication, Magellan is a patchwork of parts from other spacecraft programs in order to save money. The large antenna was left over from the Voyager program. In the command and data system, which is the brain used to operate the spacecraft, came from the Galileo program. One test article was borrowed from the Voyager backup spacecraft hanging in the Smithsonian. In the interest of economy, the program, which started back in the early 1970s, sacrificed many planned experiments primarily related to learning more about the atmosphere.
Ingress and egress of the firing room will not be allowed after...
At the present time, we are in the T-minus 9-minute hold, a 40-minute hold period to allow time for the management team and the test conductors to discuss any issues that they may have prior to picking up the count once again. Launch scheduled for 2:24 p.m. Eastern Daylight Time, a 23-minute window.
Go ahead, launch.
This is Shuttle Launch Control.
They want to make you aware they are running a special test on the Magellan spacecraft receivers at this time for the communication system, and we're going to wait for the results of that. And in terms of weather, both here and Tal site, looks like we're still good locally, and Ben Greer is hanging in there. Other than that, the management team is not working any issues. Okay, copy. And RSO NPD. Go ahead. Okay, comm check on 212. Roger, loud and clear, on me. Copy, you fly by. Roger. And C, HTD, GSS, and JBFX NPD. CGSS go. CHTD go. JBFX. Verify active on 212 and monitor 232 for the remainder of the count. TSS verified. CHTD count. Verified. JPX, copy. OTC, CCSC, 212. Go ahead. What is this special comm test that's going on, please? Stand by. This is the NPD. What they're checking is some high power level interference that they're seeing with the Magellan spacecraft. Okay, how will that affect our orbiter communication? It shouldn't bother it. We check with flight, and what they're doing is all transparent to the vehicle at this time. Okay, be advised if there's any uplink level variations, we may lose NSC frame syncs. Understand.
This is Shuttle Launch Control. We're at T-minus 9 minutes and holding. At the present time, there's just slightly more than 33 minutes remaining in this build-in hold. The NASA launch director, Bob Seek, has briefed the crew on the problem that is being worked by the spacecraft people. The Magellan spacecraft had a receiver lockup, and it's believed to have been caused or to have occurred when the Mila tracking station went from low power to high power and may have saturated that receiver. The power is going to be reduced to see if that was indeed the problem. However, the director of payload operations here at the Kennedy Space Center just reporting that the test has been completed and that the change to high power by the Mila antenna does cause a lockup of the receiver on board Magellan.
And flight NPD 212. Flight NPD 212.
31 minutes, 30 seconds remaining in this build-in hold. The flight crew heard it reported that the weather appears to be cooperating both here at the Kennedy Space Center and overseas.
NTD Flight 212.
Yes, sir.
You called?
Yes.
At the present time,
readout.
work going on to confirm that the problem with the locked up receiver on Magellan was due to that high power configuration.
And plan on picking that up about L-9.
Okay.
Magellan, in addition to sacrificing some planned experiments because of budgeting, has also sacrificed speed in order to assist the Galileo program. If Magellan could be launched at the proper time in the Earth and Venus orbital relationship, the spacecraft could have zipped over to Venus in 4 months. By giving up the best time for the trip, the Magellan scientists allowed the Galileo scientists to have the best launch period. Galileo, which is planned for launch in the fall, will travel outward to Jupiter by first going to Venus, using the mass of Venus as a slingshot to add energy and velocity to its journey and fling it outward towards Jupiter.
Okay, we are holding off on our...
In the case of Magellan, it will take 15 months by using this window, and all of the ingenuity of the mathematicians and physicists who designed the roadways through the solar system.
Copy that, sir. Copy. Okay, pick it up.
Magellan will be sent into a orbit around the sun, basically. It will cross the orbit of Venus at a time when Venus is not actually there. However, on the return time, when it crosses the orbit of Venus, Venus will be there, and it will have a firing of a motor on board, which will place it in orbit around the planet. Test activities continuing with the Magellan as other tasks in this T-minus 9-minute hold continue as well.
NPD launch director. Go ahead, launch director. Okay, whenever flight is ready, we can do the minus 25 minutes weather tag up on 231. Okay, flight, you ready?
NTD stage 20.
NTD Flight on 212.
Okay, flight, you ready for your T-minus 25-minute briefing at this time?
No, sir. Give us about 5 minutes.
All right, copy in about 5 minutes. Go ahead, HYD.
Okay, we have a LCC out of limit here, LCC 6.7.2-06, our boiler 2.
Okay. SPE? SC, okay. You on monitoring here? Yes, sir. Okay.
Yeah, we're also our boiler 2, okay. We're below the 133 temperature limit.
Okay, and HYD, saying we got a problem here at this time?
No. We had the okay prior to, the criteria is between EP cryo loading and the APU pre-start. We had the okay on. We have lost it at this time. We're below the 133. Steam vent temp, the crew should be aware that they won't get an APU okay at in the cockpit T-minus 5 minutes.
NTD SRO on OIS 212. Stand by, SRO. HYDST.
HYD.
Okay, on page 672-10, you can confirm that you did have water spray boiler okay during crowd tanking.
That's correct.
Okay, and we can invoke the procedures defined on the page, is that correct?
That's correct.
And you do not have an LCC violation?
That's correct.
Okay. Okay, and what does the crew need to be aware of at this time? Okay. HYD, which water spray boiler was it?
Okay, it's water spray boiler 2. They should be aware that the steam vent, they won't get an okay to, they won't get a ready talk back for the system 2 boiler.
Okay, and PD, when OTC gets PLT to start the APUs, he could just tell him that he may not get a talk back on APU number 2. Okay, I understand. And OTC, do copy? OTC copies. And this is an expected condition for where we are in this configuration.
This is shuttle launch control at T-minus 9 minutes and holding. We have 25 minutes and 17 seconds remaining in this build-in hold. The tests that were conducted by the payload team has confirmed that the Magellan spacecraft is ready for launch. There was a problem with a receiver locking up due to the high power condition of the Mila tracking station. However, once that was understood, it was determined that we would be able to launch today.
Number is 30RV0257. Okay, and SP, you copy launch nerd?
At the completion of its 15-month flight through space, Magellan will approach Venus almost over its north pole. A solid propellant motor will be fired to slow it so that it will be captured in an elliptical orbit by the planet. For 18 days, Magellan will be checked out and then begin a 243 Earth Day mapping mission. That's slightly more than a Venusian year. Each orbit will take about 3 hours 9 minutes, swinging as close as 155 miles and going out as far as 4,977 miles from the surface. Magellan is a smart spacecraft which can heal itself of many problems, and if it decides it cannot fix something, it puts itself to sleep temporarily to allow controllers on the ground to work out the problem. The orbit is designed so that the radar will gather information during a 37-minute period when it's closest to the surface and then play back the information to Earth as it flies outward to the furthest point in its orbit. The Magellan science team includes members from 5 nations, and although they will have enough data from the original mission to study for 10 years, they hope to extend the period of data gathering to enable the production of 3-dimensional maps and to fill in gaps caused by shielding of the Earth from the spacecraft by the Sun or Venus itself. Activity continuing here in the T-minus 9-minute build-in hold. We have 23 minutes remaining before picking up the count once again.
Stage 14.
Go to 161, please, sir.
Okay, copy.
And SPENTD. That's okay, the IPR on the boiler problem, that is not a constraint to launch at this time. Is that correct? Okay. Launch vector, escape weather on 231. Cape weather, go to 231, you're on 212. Understood.
This is shuttle launch control at T-minus 9 minutes and holding. We have slightly more than 20 minutes remaining in this built-in hold. The plan is to pick up the countdown at the at 2:15 p.m. and lift off at 2:24 at the present time. We do have a problem in the range safety area. One of their cyber computers is down, and this is used for a lot of the tracking information and processing of information during the ascent phase when range safety is watching very carefully to make sure everything is operating properly. We'll be standing by to see if that computer comes back up. There will be a status check that will occur approximately 6 minutes before we come out of this hold, just about 9 minutes from now, to determine what the status is. At the present time, we're at T-minus 9 minutes and holding. This is shuttle launch control.
CDR, go.
Okay, just to bring you up to speed, I guess we're looking at two problems at this point in time. One is dealing with the Magellan spacecraft itself, and the other one is a computer system utilized by the range safety folks. And
Okay, we've been following what we could hear of that.
Say again, sir?
And we have been following what we could hear of that on the loop.
Okay. And we're approximately 19 minutes away as far as our picking up the count at -9 is concerned.
Advance, roger that, NTD.
NTD, PTC.
Go ahead, PTC.
On that little problem we were troubleshooting a little while back on the Magellan, did you get the report back from JSE Payload Ops?
No, sir.
They took the power from 10 kilowatts down to 2 kilowatts. Magellan lost a lock on the signal, and what they did was they took it back up to the full power rating. They locked back up on the signal. Now that Magellan understands the problem, they don't consider it a problem anymore, and they're going to still go for launch.
Okay, I understand that Magellan is go for launch then.
At this time, yes.
Okay, I understand.
NTD SRO on OIS 212.
Go ahead.
Roger, the 0-90 minute Jim sphere was terminated at 56600 feet, 56,600 feet. Data was transmitted to JSC loads.
Copy, thank you. And any estimate on your computer?
Negative, not yet.
Okay. NTD SD 232. Go ahead, SD. Okay, what was the water spray boiler IPR?
257.
Okay, and did you give one to the range?
No, I did not.
That would be 258. SPE, NTD. SPE, NTD, 212. Stand by, NTD, you'll be right with you. Okay. Go ahead, NTD. Okay, you're requesting go ahead and generate an IPR on the fiber problem. That's your call, NTD. Okay, I don't know that we've done that in the past, so I don't think we'll pick one up this time. ISL 212. Go ahead, ISL. Did I have CMQC on 145? CMQC OTC.
I copy.
Yeah.
NTD flight 212.
OTC, CMQC.
Go ahead. Go ahead, CMQC.
Oh, okay. We need, if CNGC can get in here, we need a signature for him for a pin and ink, but no particular hurry.
Okay, that's GNC.
That's for me.
Okay, GNC, you copy?
GNC copies.
ITD, NTD, 212. ITD, NTD, 212. TTC, NTD, 212.
Go ahead, NTD.
Can you get ITD over on 212, please?
This is ITD. Go ahead.
Roger, just to give you a heads up here, what we're looking at doing is going ahead and picking up at L-19 as though we were coming out of the hold and going down, and breaking out if we can't get an SRO go prior to picking up the count. Does that bother you as far as doing your L-15 full-far checks?
You would pick up at L-19, and then we would go ahead and do them at L-15 as planned.
Yeah, what we'll do is we'll run the count just like we're doing it, and break out at -9 if we don't get a range go by that time.
Well, this launch director clarification will hold it, continue to hold at 9 minutes if we don't have a go until the range clears their problem.
That's correct. My concern was, can you go ahead and...
This is shuttle launch control at T-minus 9 minutes and holding. We have just slightly more than 12 minutes remaining in the standard part of this hold. We have approximately 36 minutes until the end of the window. The plan at the present time is to go into the checks, which occur about 6 minutes prior to picking up the count, and to see whether the range safety people have been able to get their computer working again properly, and whether we can get a go to pick up the count. This is just a 23-minute window today. The window gradually increases to almost 2 hours as we go through the month. The crew has been briefed by the team about the one transducer that's on board that is not reading the cabin pressure properly. It's believed that there may be a cap on that one sensor. However, that's not a violation of the launch commit criteria. and we can fly with that, and they can take a look at it after they're on orbit.
Both observation and
But at the
forecast
present
weather
time,
at KC and
except
Ben-Guerir
for
are go.
the problem with the
KSC
range
15,
safety computer,
forecast
we
altimeter
appear to be
29,
go.
9.
There's 10 minutes,
Forecast
44
altimeter for
seconds
Ben-Guerir,
remaining
runway
in this
36,
40-minute build-in
30,
hold, and we'll be standing by for a status check of all of the various test conductors who are in charge of today's launch just about 4 minutes from now. This is Shuttle Launch Control.
NTDSD 212. Go ahead. Okay. Do we have any constraints left? The only one I show is at item 171, which is IPR 256. Okay. They're in the room closing it out right now. Okay. Okay, and we're about 10 minutes away from coming out of the hold at -9. ITD, NTD.
Go ahead, NTD.
Okay, we'd like for you to go ahead and perform your whole part checks by the clock at L-15 minutes.
Roger, we'll be doing that.
Okay. And flight, NTD.
This flight?
Okay, can you activate your recorders at L-15?
Wilco, I hate to do that if we hadn't got to go from the range yet.
Okay, about how long will that take once we give you a go?
It won't take but a minute.
Okay. Okay, all personnel on 212 at this time, I'd like to go ahead and get a verification that you're ready to resume the count and go for launch, realizing that unless we get a go from SRO and the computers get back up, we're still in no-go. OTC? OTC's ready. PBC? PBC's ready. PTC? Go. LTS? LTS will go. Flight? Flight NTD, 212. Mila? Mila's go for launch. STM? STM go. Safety console? Go. SDE? SDE's go. CDR?
CDR is go.
All right. LRD?
LRD's go.
And the SRO?
SRO still no-go. We should have word shortly.
Okay, I understand. And Houston flight?
And flights go.
Okay.
This is Shuttle Launch Control.
Director,
Our NASA test director now calling the launch director.
okay, I can verify that the launch team is ready to proceed with the exception of the SRO getting his computer back up, and we still have to activate the recorders.
I copy, and I'll be back to you in a couple of minutes after we've had the final brief with the mission management team.
Understand?
Launch Director Bob Seek talking to NASA Test Director Ron Phelps. The Ron Phelps reporting that everyone is go, including the Mission Control Center in Houston at this time, with the exception of range safety, which has a computer problem. The range safety officer reported that he should know in just a couple of minutes whether or not that's going to be able to be brought back up. At this point, Launch Director Bob Seek and the Mission Manager Bob Crippen consult on the readiness and all of the possible issues, and then report back on whether they are go.
Mark, we're approximately 6 minutes away from coming out of the count. SPE, NTD. SPE. Roger. Do we need to brief the crew as far as the pressure transducer is concerned? Flight's going to take care of that. Well, Flight just asked,
And this launch director, why don't we go do that at this time? SPE, why don't you just give a brief overview and Flight can add if they wish.
okay.
Wait till at the end.
CDR, SPE.
Sure, listening.
Okay, CDR, during the cabin pressure test, we found that the cabin pressure sensor did not change. And the data is showing us that we have some anomaly with the sensor that is keeping it from changing state. However, the airlock differential pressure and the DPDT do work. And we want to make sure that you understood that your cockpit meter would not reflect any change in cabin pressure.
Okay, we do understand that.
And
We believe that also we may have a problem with the backup DPDT comp on SM System 1, is that correct?
And Flight concurs with that, Dave. You will have a problem with that
Okay, we
backup.
think we understand the situation.
And NTD, this launch director, I'll run part of my polling at this time. Start with payload operations. Yeah, Bob, this is John. We're go for launch this time. I copy. And engineering director?
Launch director, I pulled the technical community, and you have our consent to proceed with this launch. Good luck and Godspeed.
Copy. Safety and quality director?
KSC safety and quality have no constraints for launch.
Copy. And Cape weather?
Cape weather, we have no weather launch constraints violated. Steady state winds for launch from 110 degrees at 12 knots.
Copy, and that will give us a 7-minute hold capability after APE start if that is required.
NTD, PTC.
Go ahead, PTC.
Okay, steps 854, 855 are complete.
Copy.
Also, steps 991 are complete, and our ASC batteries are online for IUS. Steps 1014 through 1017. At this time, we'll go ahead and report that they're complete. We're ready.
Copy. Magellan's ready to resume the...
Magellan and IUS are ready.
Okay.
This is Shuttle Launch Control. We have about 2.5 minutes remaining in the planned part of this hold. We're about to hear Launch Director Bob Seek and Mission Manager Bob Crippen discuss the readiness to go.
Countdown clock will start in 2 minutes on my mark. 3, 2, 1, mark.
Ops manager, launch director.
Roger, go ahead, launch director.
Okay, want to confirm you have a go to proceed.
Roger, you have a go to continue with launch from the mission management.
I copy. And NTD?
NTD, go.
Okay, what's the status from range safety at this time?
SRO? NTD SRO, we're still no-go, waiting
Hold
for
on.
further word from safety.
This is Shuttle Launch Control, a report from the range safety officer.
Yes, sir, go ahead. Okay, we'll want to cancel pending. I copy.
The range safety computer is still not up. It's been announced that we will not be coming out of the hold on time.
NTD, ITD.
Go ahead, ITE.
Hold fire system is enabled.
I copy.
We have about 24 minutes 45 seconds remaining in the capability to hold. That's a 24-minute or 23-minute launch period for today.
Hold on that.
We were supposed to come out of the hold at 2:24 p.m. Eastern Daylight Time. As it is, we are standing by to listen to a call from Range Safety about whether or not they are able to get their cyber computer back up and operating.
Configuration. I copy. And PVD to copy.
I copy. We'll proceed with payload bay flow rate reduction.
Understand.
At this point, we have had a check of all of the various test conductors who are monitoring today's launch.
We can get a confirmation from the range on their estimate here to try to clear the problem. What I'd like to do, if it looks like they're going to be having some success there, to go ahead and pick up the clock and put a hold pending in at -5 minutes and go back into a hold there if there's still no go. SRO copy.
I copy. I'll have to discuss that with the range safety officer.
NASA Launch Director Bob Seek proposing a plan to pick up the count and proceed down to the 5-minute point and then hold once again if the range safety computer has not come back up. At this point, all elements of the launch team and the mission management team have concurred that they are go. The range safety cyber computer is the only problem at the present time.
QC.
Go ahead.
Okay, constraint. Line item 171 is lifted.
Copy.
The Superintendent of Range Operations conferring with the range safety officer on the plan to pick up the count and proceed down to the 5-minute point. We should hear back from that shortly. 22 minutes and 12 seconds remaining in the window.
Go ahead, PD.
Okay, flow rate reduction is complete. Be advised that we dipped a little bit below the LCC when we were ramping down. They were back at normal interface pressure.
I understand. Thank you.
And,
A report coming back on the reduced flow rate of air through the payload bay.
I copy.
That 21 minute and 45 seconds remaining in the window for today's launch takes into account that we would be starting at the T-minus 9-minute point. So it's really about 30 minutes before the close of the window. However, we have some very significant things to do in the remainder of the countdown before we get to liftoff. So we'll stand by.
OIS 212.
Go ahead, SRO.
Roger, you have a final clear to launch from the range.
A final clear to launch from the range computer up and operating.
NPD. 212.
Roger, copy that. Atlantis, launch director.
Atlantis, go.
Okay, well, I think we finally got everything cleared up down here, Dave. Your payload and shuttle are in great shape, and the ground systems are in a support mode, so we'll wish you a good one. And NTD, you have a go.
Go ahead, launch director.
Roger, you have a go to proceed.
I understand.
And NTD Flight 212,
Go ahead, flight.
we will have a mode boundary update for the crew here as soon as we can get it. You can press on.
Okay.
So shuttle launch control standing by for word from the NASA test director.
Flight, CISL, COEX, and JRPS, go ahead and activate the recorders at this time.
Flight copies. And work.
ISO copies.
OAS copies.
Okay. And
TLS, why don't you go ahead and pick up the count on your mark.
I copy. Stand by, please.
Okay.
We'll see for 1820 GMT.
And flight, NTD.
Does flight go?
Okay, I did interpret that as you got to go at this time to pick up the count.
That's affirmed, and we do have the boundaries to read to the crew.
Okay.
You ready to go ahead and do that?
Go ahead.
We'll be picking up the count in just 40 seconds from now.
Atlantis, Houston, with some deltas to your mode boundaries.
Ready to copy, Houston.
Roger, due to the slight change in launch time, new press to ATO, 11.7.
Stand by, please.
Press to MECO,
Countdown clock, resume on my mark.
13.6.
2, 1, mark. T-minus 9 minutes and counting.
And we're at T-minus 9 minutes and counting, the countdown clock proceeding. The ground launch sequencer has been initiated, and from now till T-minus 31 seconds, when we begin to switch over to the onboard computer, that will be in command. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the onboard computers, which then report back that the commands have been executed. 8 minutes, 30 seconds, and counting.
10:30, not performed. Yes, stand copy. Thank you. EISL. Go ahead, ISL. Recorder's activated. Copy.
The recorders have been activated. T-minus 8 minutes, 15 seconds, and counting. The primary job of the onboard computers is to check that all of the launch commit criteria are within limits. Coming up on the 8-minute point.
Yes, sir. Can proceed with transmission of stored program commands.
Wilco?
It's in work.
We've passed the 8-minute point, and the crew has been notified and flight notified that they can proceed with the stored program commands. This is a final update on antenna management and frequency changes. This ensures the orbiter has the latest information to speak to the TDRS satellites and ground stations. T-minus 7 minutes, 30 seconds, and counting, and the orbiter access arm is retracting. This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, the arm can be placed back into position within about 15 seconds. Coming up on the 7-minute point in our countdown.
Start your APU and hydraulic recorders by the clock at 6 minutes. I copy.
T-minus 7 minutes and counting. Everything proceeding smoothly as we move down towards a liftoff at 2:29 this afternoon. T-minus 6 minutes, 40 seconds and counting. Pilot Ron Graby will be asked to set the switches in the cockpit to the pre-start position for the auxiliary power units, or APUs, at the 6-minute point. This consists of positioning a number of switches and verifying that they are in the proper position, then throwing the 3 propellant isolation valve switches, which allow the hydrazine fuel to start flowing from the tanks toward the APUs. Coming up on that 6-minute point in 12 seconds.
TLT, OTC.
OTC, TLT.
Sir, perform APU pre-start.
APU pre-start and work.
Pilot Ron Graby reporting that pre-start is in work. T-minus 5 minutes, 45 seconds and counting. In just a few seconds, Mission Control will transmit the signal to start the onboard flight recorders.
OTC, TLT, APU pre-start complete. Great talkbacks on 1 and 3, barber pole on 2.
Copy that.
Pilot Ron Graby reporting pre-start is complete. At the T-minus 5 minute point, the orbiter test conductor will ask Pilot Ron Graby to start the auxiliary power units, which provide hydraulic power for steering and controlling the flight surfaces. 10 seconds away from that 5-minute point.
PLT, OTC, perform APU start.
OTC, PLT, APU start and work.
And CDR, OTC, reconfigure heaters.
Pilot Ron Graby now flipping the 3 switches in the cockpit to start each of the 3 APUs. The liquid oxygen replenishing of the LOX tank has been terminated. At this point, the liquid oxygen fill and drain valve is closed, and at the same time, cold hydrogen gas is flowing through the main propulsion system to
GTQ on APU 3 at 6.6-7. We're still going to 1 and 2 man towards instrumentation only. Copy that. And PD copy. SP copy. SP copies. This OTC.
OTC.
T-minus 4 minutes and counting.
Go for purge sequence 4.
The main engine final purge sequence is underway, and the orbiter flight control surface such as elevons, speed brakes, and rudders are now being moved through their pre-programmed position to verify they are ready for launch. T-minus 3 minutes 40 seconds and counting. T-minus 3 minutes 30 seconds and counting, with all 3 engines now being moved through a pattern to verify their readiness for ascent flight control. After going through their pattern, they will be aligned to their start positions. We're coming up on the 3-minute point. At 2 minutes 55 seconds, the start of the external tank liquid oxygen pressurization will begin. T-minus 3 minutes and counting. The ground launch sequencer has sent a signal,
LO2 pressurization.
has started to retract the gaseous oxygen vent hood or beanie cap on the external tank. The computers will make a final check to ensure the vent arm is fully retracted at the T-minus 37 second point. T-minus 2 minutes 30 seconds and counting.
OTC, PLT, go.
Clear caution and warning memory and verify no unexpected errors.
The orbiter test conductor has asked pilot Ron Graby to clear the caution and warning system. He's reported there's no unexpected errors. T-minus 2 minutes 12 seconds and counting. Liquid hydrogen replenish of the external tank will stop in 5 seconds and pressurization get underway.
Close and lock your visors and initiate O2 flow. And have a good flight. And PLT, OTC, turn on debris camera at T-minus 10 seconds.
Let's go for ET LH2 pressurization.
Orbiter test conductor Mike Key telling the crew to close their airtight visors.
Thank you for this fire station.
Coming up on the 90-second point, 90 seconds, and we're less than 2 minutes away from launch of STS-30 and its crew of 5. At the T-minus 1 minute point, the ground launch sequencer will verify that the shuttle main engines are ready to start. The liquid hydrogen tank now at flight pressure. Coming up on the 1 minute point in our countdown. T-minus 1 minute and counting. The liquid hydrogen tank at flight pressure. The sound suppression water system now armed. Pre-liftoff water will...
31 seconds due to an RSLS hold.
We will hold the clock at T-minus 31 seconds. We have had a report. We will hold the clock at T-minus 31 seconds.
Stand by, sir.
This is to me, we launched low pressure fuel pump discharge press, engine 1.
The countdown clock
We're
is holding at T-minus 31 seconds.
We're at T-minus 31 seconds and standing by to hear what the problem is.
We're going to have to recommend a recycle here. It looks like the pump is actually down.
Okay, Launch Director SP, is there anything else we can look at here before we go to a recycle? See prop, anything else?
Negative, we've lost research on this engine. We're out of limits. We're out of engine ready.
Okay, NTD, let's recycle. And this Launch Director
Flight 212, we're going to go ahead and clear our SPCs.
Copy.
Launch Director Bob Seek telling the NASA Test Director that he has a go to cut off and recycle. At this point, there would not be enough time to recycle and launch today. The orbiter access arm being placed back into position against the orbiter to allow the crew to egress at the proper time. However, there is no problem with the recycle at this time. There's no danger to the crew.
Perform APU shutdown. Roger, APU shutdown and work.
Pilot Ron Graby reporting that he has APU, auxiliary power unit, shutdown in work.
Fire detectors tripped at this time.
And NTDC prompt. Go ahead, C prompt. Yeah, the engine 1 pump did come back online. It looked like it was cavitating, so we terminated all 3 reset pumps. Copy.
The launch team going through a recycle from the T-minus 31 minute or 31 second point. They'll be going back to T-minus 20.
Yeah, we're calculating. We'd like to give that to you post-test. Okay, copy that. CDO and PLT OTC. Perform cutoff safing switchover. Okay, interrogative the heater activation.
The test team going through the process of recycling now from the launch configuration. The countdown for launch of STS-30 and the Magellan spacecraft to Venus halted at just 31 seconds prior to launch. Problem with the recirculation pump is what has been mentioned. We're standing by to hear more information on the problem which occurred. The gaseous oxygen vent arm or beanie cap being replaced on top of the external tank to carry away any vapors boiling off from that tank.
GPC mode 5 switch to standby. It's in standby. Copy, panel R1. PLT, power distribution essential bus source. Fuel cell 1, 2, and 3 switches to off. Copy, essential bus source 1, 2, and 3, essential bus to fuel cell coming off. Copy that, and PLT on panel F8. Flight controller power switch. PLT. Flight controller power switch off. OTC PLT, flight controller power is off. Okay, copy that, thank you. CGSS OTC. CGSS verifies OA is extended and locked. Copy.
So shuttle launch control, the flight crew, primarily Commander Dave Walker and pilot Ron Graby, in the cockpit doing the necessary switch throws to safe the orbiter. They have shut down the auxiliary power units and have shut down the fuel cells which are used to produce electricity while in orbit. In the meantime, the launch team continues to go through the necessary procedures in order to recycle the countdown back to the T-minus 20-minute point. And we're standing by. We have heard that there's a recirculation pump problem that caused us to be outside the limits of the launch commit criteria. However, have not had an explanation of exactly what happened.
To GNC9. Copy that, DPS OTC. STS, OTC.
This is DPS, we copy.
Okay.
CDR, CDPS.
CDR, go.
Panel C2, right CRT, select switch to 3.
Wilco.
And CRT 1, 2, and 3 major function switches are GNC.
That's complete.
On the right keyboard.
Go ahead.
Message reset.
Complete.
Up 000.
Okay, you want this on the pass of the VFS, CPDS?
I want this on the BFS.
Okay, we'll do it on the VFS. I understand you want an ops 000 Pro.
That's right.
Okay, that's complete. And break for OTC, CDR. Give me some words on whether or not you want the heater activation called for in the recycle procedures or not.
This is Shuttle Launch Control. The launch team still in the process of recycling from the T-minus 31 second point. Right at this point, there is really no additional information on exactly what the problem is. Although a recirculation pump has been mentioned, it is also possible that there might be a sensor problem or some other type of problem, so it is premature at this time to make any conclusion. The mission manager, Bob Crippen, is standing by for an explanation from his mission management team as well.
Copy that, NTD, you copy. And DLT, you have a go to shut down the heaters. NTD, KBC. Go ahead, PBC. Yeah, for 0037, ET heaters have been activated. Copy. Okay, all personnel on 212, stand by for post-cutoff safety checks.
The launch team about to go through the safety checks to determine that the vehicle is in a safe condition.
Verifies number 1. DPS.
DPS verifies.
SME verifies 3 and 4.
CCME verifies 2.1. MPL verifies 5 and 6.
LA fly. LA fly, NTD, 212. Julie, go ahead. Do you verify item 7 and 8 and 9? Verify. C-Lox. C-Lox verifies 10, 11. ATD. Horace, you're on 245. ATD, NTD, 212. This is ATD, go ahead. Can you verify item 12?
We can verify.
Okay. CGSS.
CGSS verifies item 13.
APU.
APU verifies 14.
BHY.
CBHY verifies 15.
EPD. EPD verifies 16, 17 does not apply. OOF. COOF, NTD.
Go ahead.
You verify 18.
That's firm.
C-Power. C-Power verifies 19. And DRS. DRS verifies 20. Okay. RSR NTD 212.
Go ahead.
Okay, post-cutoff safety checks complete. Fire and leak detector status is satisfactory. Request concurrence to proceed with SRB SNA safety.
RSR concurs.
Okay. OTC NTD. Go ahead. Pick up with step 42 SRB RSS SNA safety. Copy that. C-Power OTC.
C-Power, go ahead.
Verify ignition SNA safe.
That's verified.
Copy that. And DPS CPD.
Copy. DPS copies.
DEU equivalent critical commands will be issued momentarily. GLS OTC.
Go ahead.
Perform SRB RSS SNA safing. Post G9 recycle.
I copy and work.
This is Shuttle Launch Control, the launch team continuing to go through their paces and the vehicle.
Yes, sir. We see, we believe we may have missed a step on L2. We need to get the flash event feed line heaters to the 2.
CDR or OTC? CDR. Okay, panel L2, flash event feed line heater, A and B supply switches to 2. That's complete. Thank you, sir.
Pilot Ron Graby being asked to flip one more switch, which has to do with heaters on the water spray boilers.
ISL OTC.
The vehicle in a safe condition at the present time, but still a lot of work to do to get it back into the T-minus 20 minute point and then recycle it completely.
Panel C3.
At this point, we are standing by to learn more about the problem which caused the scrub of today's launch at the T-minus 31 second point. The recirculation pumps which provide for the proper configuration of the main engines prior to engine start appears to be a problem.
Hi, crew, welcome.
This could be a ground support problem, but it's too early to say that definitely.
TBC and yes, TBC. Okay, you want to go ahead and kick off step 61? TBC, copy. PLT, OTC. OTC, PLT, go. Yes, sir, on panel R2. Go ahead. APU hydraulics, APU controller power, 1, 2, and 3 switches off. Roger, APU controller power, 3 switches are off. Copy, and hydraulic main pump press, 3 switches normal. Hydraulic main pump press, 3 switches are normal.
Just as during the launch countdown, a recycle of the launch vehicle proceeds according to procedures as part of the total 5-volume set of procedures that are used for preparations for launch, and then recycle or any contingencies that might occur.
MPS helium ISO A, 3 switches GPC. And helium ISO B, left, center, and right switches GPC. Helium ISO B, 3 switches to GPC, complete. Pneumatic helium ISO switch, GPC. That's complete. Copy that, thank you. CLHY TDC, you go to 136, please. Okay, all personnel on 212. At this time, the decision has been to scrub for today. We will not perform steps 59 and 60. And we'll pick back up on page 984 with step 62. TBC? TBC, NTD. TBC, NTD 212. TBC, NTD 212. TBC. Okay, you've got step 61 in work, and I'll give you step 62 at this time. I'm sorry. It is TBC on 212. Okay, 62 is not performed, so you're working 61. That's right. 62 is not performed. 61 is in work. Okay. Complete. And OTC is critical safety complete? It is complete, sir. Okay. And OTC, TBC, could I have a DPS on 136?
And step 64 is not performed.
Yeah.
Okay, and OTC NTD?
Go ahead, sir.
Let's go ahead and put step 65 in work.
Copy that. GNC, OTC. CGNC, OTC, 212.
Go ahead.
Okay, step 65, sir, on page 985.
I copy.
And OTC, DPS, step 66 and 67 are complete. Copy that. NTD, TBC.
Go ahead, sir.
Okay, the shuttle range safety system are powered down, and range safety SRS vehicle power is off. ETR carrier no longer required.
Copy.
NTD, SRO, and OIS 212. PVD, OTC 212.
This PVD.
Yes, sir. You want to go ahead and pick up on step 80, increasing your payload bay flow rate.
Didn't work now.
NTD, PTC.
This is Shuttle Launch Control. We have just passed the point where we were 1 minute away from the usable launch window. Of course, we knew immediately at the point that we scrubbed at 31 seconds
Give DPS step 66 to assign us.
that we would not be able to recycle in time.
Got it, sir. I copy. Thank you.
At the present time, we are still standing by to hear additional information about what actually happened. We know that the report was that the recirculation pumps, which are used to keep the engines in the proper condition prior to start, was not functioning properly in the case of engine number 1. However, it may be, the problem may not be related to the engine at all, but to the ground power source or to something in the orbiter. At this point, there really is no way of saying that. As we go through the recycle, and the first order of business with the launch team is to make sure that everything is safe, to get the crew out of the orbiter and to get them back to the crew quarters out of their suits, and then they will have lunch. The windows for launch continue to get larger as we go through the window. The opening of the launch window tomorrow, instead of being at 2:24, would be at 2:18, and then on Sunday would be at 2:13. On May 1st, it would be 2:07.
NTD,
And the duration of the window would go from 23 minutes today to 30 minutes tomorrow to 36 minutes, then 43, because as it opens earlier, the amount of time available before sunset over at the transoceanic abort sites increasing. Standing by as the launch team continues with the recycle procedures.
your normal command channel.
This will result in a recycle back to the T-minus 20-minute point, and at that point then we will be beginning the egress procedures with the crew. This is Shuttle Launch Control.
TBC, NTD.
TBC.
Okay, can you verify ET locks and stable drain?
Stand by.
Okay.
NTD TBC.
Go ahead.
We can verify wind stable train.
Okay, and ETLH2 in terminal count safety.
That's correct. TBC.
Okay, and ET recycle is complete.
That's correct.
Okay. OTC and TD.
Go ahead.
Will you want to do any cockpit securing?
That's affirmative.
Okay, why don't you perform your cockpit securing sequence 19 at this time.
Copy that.
NTD, PTC.
Go ahead, PTC.
Any indication on when Milo is going to start reducing their power? We're taking a lot of telemetry hits at this time. We're afraid to loosen a spacecraft string.
Yeah, OTC Milo can take that down at this time.
Go ahead, TVC. Okay, stand by.
OTC CGNC.
Go ahead.
Step 68 through 72 complete. 73 through 77 not performed. 78 not performed.
Okay, copy that.
OTC CPVD.
Go ahead, PVD.
Sequence 18, step 81 is not performed. 82 was performed. The flow rate is 230 pounds per minute. And step 84 is not performed.
Copy that. PLT, OTC. OTC, PLT, go. Sir, I'd like to go ahead while they're on their way out there and try to get some of our cockpit securing done. Standing by. Okay, panel 08. Go ahead. Left on tank isolation, A switch, GPC, talkback, open. That's complete. And B switch, GPC, talkback, open. Also complete. Copy, left ohms cross feed, A switch, GPC, talkback, closed. Complete. And B switch, GPC, and give me a talkback position, please. B switch is GPC, talkback is closed. Copy. Right ohms, tank isolation. A and B switches, GPC, talkback, open. Complete. Copy. Right ohms cross feed. A and B switches, GPC, talkback, closed. Complete. Forward RCS, helium press. A and B switches, GPC, talkback, open. That's complete. Copy. Tank isolation, 1, 2 switch, and 3, 4, and 5 switch, GPC, talkback, open. Complete. Manifold isolation, all 5 switches, GPC, talkbacks, all open. All manifold ISO GPC, talkbacks open, complete. Copy that. OVCC OTC net 105. Yes, sir. You can proceed to pad for flight crew egress operations. Portable O2 meter is required to check O2 contents in white room. Thank you. Okay, and PLT OTC. Go ahead. On panel 07. Go ahead. Aft left RCS, helium press, A and B switches GPC, talkbacks open.
Complete.
Standby 1 PLT. Go ahead, OVCC. Copy that. Okay, stand by. You should get cut loose momentarily. PLT, OTC.
OTC, PLT, go.
Okay, sir. Manifold isolation. 5 switches, GPC. All 5 talkbacks open.
Okay, all left RCS manifold isols GPC open. Okay, that's complete.
Copy. After right RCS, helium press, A and B switches to GPC and talkbacks open.
That's complete.
Copy. Manifold isolation, 5 switches, GPC, 5 talkbacks open.
That's complete.
Okay, copy that. And on 014.
We'll try.
Okay, on row F, RJDA 1A, L2R2 manifold, driver and logic switch to off.
Okay, 1A driver and logics are off.
Copy that. 2A, driver and logics off.
That's complete. 2A driver and logics are off.
Okay, and RJD F1B, F1 manifold, driver and logic switches to off.
That's complete.
And left ohms engine valve switch off.
Left ohms engine valve is off.
Copy. 015.
Go ahead.
Row F.
We're ready.
RJDA 1B, driver switch off. And logic switch off.
Complete.
RJDF 1A,
Go ahead.
driver off and logic off.
Driver and logics off.
Copy. 016.
Okay, it's complete.
Okay. Panel 016.
Go ahead, sir.
Okay. RJDA 2B, driver and logic off.
Complete.
And RJDF 2A, driver and logic switches off.
Complete.
RJDF 2B, driver and logic switches off.
Complete.
And RJD manifold, driver switch off. Verify.
That's verified, sir.
Copy. Right ohms engine valve switch off.
Right ohms engine valve off.
Copy.
Complete.
Thank you. CDR OTC.
CDR, go.
Yes, sir, on panel C3.
Okay.
Ohms engine, left and right switches off.
That's complete.
Copy. COOS OTC. COOS OTC 212.
Double S, go ahead.
Yes, sir. Step 33 in sequence 19. You verify.
That is verified.
Thank you.
CMPS.
PLT OTC.
OTC, PLT, go.
Yes, sir. Panel R1.
Go ahead.
Power power distribution and central bus source. Fuel cell 1, 2, and 3 switches off. That's notified. Copy. Q, ISL OTC. CISL OTC.
This is ISL, go ahead.
Yeah, 19035.
That's already been performed.
Okay, so we should not perform that, not perform ISL the next 5 steps, or 6 steps?
That's correct.
Thank you. And CDR OTC. CDR, go. Yes, sir. Panel 07. Okay. TACAN 1, 2, and 3. Mode switches off.
This is Shuttle Launch Control. The launch team continuing to go through the recycling process here, getting everything into the condition where the crew can leave the orbiter and return to the crew quarters. At this point, no announcement has been made as to when we are going to recycle, whether that would be tomorrow, the next day, or even further. A meeting has been scheduled for 3:30 in which all of the data will be assessed by the managers and the engineers involved in the process. Following that meeting, there will be an announcement as to what the outcome of it was, what sort of tests might be necessary, and when we will try again. At the present time, the problem involves engine number 1 and the recirculation pump, which is used for moving hydrogen and oxygen around in the engine prior to the actual engine start. That is powered by a ground system. However, at this point, there's no indication as to exactly where the fault lay. A meeting of engineers and managers will occur at 3:30. Following that, there should be an announcement as to the next proposed launch date and what the plan is for doing the troubleshooting, fixing whatever the problem is, and then proceeding on. The flight crew is in the process of continuing their preparations in the cabin and to leave the cabin at the appropriate time. We'll be standing by here for the egress of the flight crew, and then standing by for an announcement following the 3:30 meeting as to what the plan for recovery and launch is.
Since we lost 3 out of 6,
there were a number of issues that were worked as we went through the countdown today, and in the end, all of them were cleared up, and something that had not been expected caught the team by surprise and resulted in the countdown being terminated. The Magellan spacecraft had a problem when its receivers were saturated by the Mila tracking station going to full power. Once that was understood, the Magellan was cleared for launch. It appeared that we might have a weather problem. The crosswinds at the shuttle landing facility were very marginal and probably in violation earlier in the day. But as expected and forecast by the weather forecasters, the wind shifted around from the southwest to the southeast, and at the time of the proposed launch, conditions were satisfactory. There were some marginal conditions overseas. However, it turned out that everything was go. at the time of launch there also. Almost at the last minute, there was a problem with the range computer. That was brought back up online with only a few minutes lost and plenty of time to launch. And in the end, at T-minus 31 seconds, the clock was stopped when a problem with the recirculation of hydrogen and oxygen through engine number 1 ran into trouble. And at this point, there has not been a determination of exactly what caused that problem. An announcement as to the next launch attempt and the troubleshooting plan will be made following a meeting at 3:30 this afternoon. This is Shuttle Launch Control.